Previously, we saw that the p-series sum n equals 1 to infinity 1 over n to the p converges if p is greater than 1. Next, we'll think about what happens if p is less than or equal to 1. We'll need to consider the cases p less than 1 and p equals 1 separately, so let's start with the case where p is less than 1. Again, we're going to look at the integral 1 to infinity 1 over x to the p dx. We'll use the integral test. We'll rewrite this as a limit. Limit t goes to infinity, integral 1 to t. We know we're going to take an integral, so we'll write 1 over x to the p as x to the minus p. So when we integrate, we add 1 to our exponent, so we get limit t goes to infinity, x to the minus p plus 1, and then our coefficient becomes 1 over minus p plus 1, and we're integrating from 1 to t. So we'll rewrite this as limit t goes to infinity. Our constant out front, that 1 over minus p plus 1, we'll write as 1 over 1 minus p. And I'll just pull that out front. And then we've got t to the minus p plus 1 minus 1 to the minus p plus 1. So let's think about what happens as t goes to infinity. So we've got limit t goes to infinity, 1 over 1 minus p. Now minus p plus 1, so I'm going to write this as t to the 1 minus p plus 1. We can just rewrite as 1 minus p. And then I just have that 1 to anything is 1, so minus 1 on the end. Now remember, we're in the case p less than 1. So p less than 1 tells us that 1 minus p is actually greater than 0. So p is less than 1. So, for example, p could be a half, in which case 1 minus p would then be a half, which is greater than 0. Or maybe p is minus 7, then 1 minus p is 8, which again is greater than 0. So as t goes to infinity, we have t to some positive number. So as t goes to infinity, t to a positive number is going to infinity, which tells us that in this case, our improper integral diverges. So the improper integral diverges, which tells us that our series also diverges by the integral test. So we say that the sum, the p-series, sum n equals 1 to infinity, 1 over n to the p. So this series diverges if p is less than 1. And again, we used the integral test to determine this. So one more case, let's look at what happens when p is equal to 1. So if p is equal to 1, we get integral 1 to infinity, 1 over x to the 1, so just 1 over x dx. Rewriting it as a limit gives us limit t goes to infinity, integral 1 to t, 1 over x dx. Integrating 1 over x gives us limit t goes to infinity, natural log of x evaluated from 1 to t. So we get limit t goes to infinity, natural log of t minus natural log of 1. Now natural log of 1 is just equal to 0, but as t goes to infinity, natural log of t goes to infinity, which tells us again that our improper integral diverges. So again, using the integral test, we conclude that the sum from n equals 1 to infinity of 1 over n, so our harmonic series, diverges again by the integral test. So to conclude, we have our p-test for series, which tells us that the p-series sum n equals 1 to infinity 1 over n to the p converges if p is greater than 1, and diverges if p is less than or equal to 1.